Want to level up your design and web development skills with mind-blowing 3D experiences right inside of a website? Well, congrats, you clicked on the right video. This crash course led by Jesse Joe will teach you the fundamentals of ThreeJS and set you on your path to creating stunning 3D experiences.
Ôm lại lại nè. Ôm lại lại.
Jesse, a seasoned expert in 3D design and web development, has won multiple web design awards and currently leads the 3D team at Moment as their technical product lead. And he was kind enough to give away the first 7 hours of his complete ThreeJS bootcamp course so that you guys can get started learning the fundamentals, including core principles and components. But you won't just be learning theory. Trust me, you'll be getting your hands dirty. Jesse has included an exciting project where you'll get to build a 3D model of the solar system, allowing you to apply what you've learned and see the results of your work in action. And for those who really want to master ThreeJS, the full course includes a project that will blow your mind. You will be creating your own personal portfolio, but with an awesome twist to make it stand out. Your own personal portfolio will be in the form of an interactive 3D web-based game with your own avatar and all. Honestly, this project can get you hired by itself. It's so damn cool. Just a heads up, in this crash course, we'll be skipping over the lighting and shadow sections of the full bootcamp course. So the resources may seem a bit out of order, but don't worry because you'll have everything you need in the description down below. Anyways, his complete ThreeJS bootcamp course is about 20 hours long, and as you can see, this crash course includes about a third of that. So once you finish up this video, make sure to check out his complete ThreeJS bootcamp course, which you can find in the top right hand corner as well as the description down below. Also, if you enjoyed this video and find it helpful, the least you could do is show Jesse some love by dropping this video a like and a comment with your questions, thoughts, or concerns down below. Alright, that's it from me. Let me hand it over to Jesse so you can start learning ThreeJS. Enjoy!
All right, welcome to the ThreeJS course. I'm so excited for you to be here. I'm excited to be here to teach this. This is one of my most favorite things to do. It's what I do for work. I love my job. It's what I actually use to actually get my job, hilariously, because someone just really loved some of the work I was doing and they're like, oh, this is crazy, like come work for us. And this library is gonna be able to enable you to do some of the craziest things that at least I never thought were possible to be able to do in the web. So if you don't know what ThreeJS is, don't worry. In the following videos, I will go into a more in-depth explanation of ThreeJS, WebGL, and related technologies. But for now, if you don't know what it is, I think the easiest way or the best way to show you is to actually show you some examples of what others have created with ThreeJS, because this is such a visually demonstrative experience. It's some of the stuff that people create are so beautiful and so visual that I think the best way to do it, to show you what ThreeJS is capable of, is actually looking at some of these examples. So I think ThreeJS had the same idea as us. This is actually their homepage, and the only thing that we see is just a bunch of examples and their menu bar on the left side. So let's go ahead and click through some of the examples. I'm reacting to this. This is the first time I'm seeing some of these websites, so because I think it's going to be cool for us to experience some of this together because of how crazy these websites are. Holy crap. So this is actually not a video, right? This is actually a 3D world. So, okay, start the journey. Oh. So already, you can imagine the crazy stuff that we're able to do within this 3D environment. Let's do it. I don't know what's happening, but I know that there's a world there that we can probably travel to. We're not going to do that for now. Let's click on something else. I know this one. This one is actually Sujin. I've seen this before. It's web versus metaverse. So they have like this metaverse type experience, but it's entirely in the web. So you can see like I was just in their homepage, and then 2 seconds later, I'm in this like 3D game, and I'm controlling this with my WASD keys. I think I can pan the camera. Yes, I can by clicking and dragging. Super cool. And I know this is their lobby, but they have another site which is like they have like a full-on metaverse, and it's crazy. It's all done on the web, and it's all powered by ThreeJS. Let's take a look at this. What is this? Oh, it looks like it's in Japanese. Oh, so that's really pretty. So look at these animations. Look at these effects. This would be really, really difficult to do in CSS, HTML, but it is enabled by our use of ThreeJS. Look at the pedals. Okay, crazy. I have no idea what it said. Next thing, let's see what else looks cool here. Well, actually, there is another thing that I could show you. Actually, before we do that, let's take a look at this. Oh, start. Oh, that's very cool. Oh, okay. So cool. Okay, so can I actually click on this? Oh, no way. Yes, I can. Okay, so you can actually... Oh, what happens if I click shut down? So this looks like someone's actual portfolio. So if I go to my showcase... okay, so you can go to their projects. Oh, it's so cool. And then what happens if I shut down? Okay, as expected. Okay, but there's one more thing I'd like to show you, because now that we're on the actual topic of portfolios, my portfolio has actually made it onto the site. So this is the portfolio that my current employer actually found before he reached out to me. So he was like, okay, like, I love your portfolio, come work for me. And I'm like, sure. And we're working on some pretty cool stuff right now. But you can take a look at my portfolio if you care about it at all. And this is what I created within 6 months of learning ThreeJS. I know some of the stuff may look daunting, may look like a really crazy experience that you may not have otherwise seen on the web, but it didn't take me very long to learn this, and I learned it on the side while I was having another full-time job. So this is definitely approachable for beginners, and I'll show you some of the stuff we can do. So yeah, this is my portfolio. So I have some of my older projects. I haven't updated this in a little bit. There's also an About Me, so you can go learn a little bit about my experiences, some of my skills. Again, a little bit out of date. But yeah, this is what I was able to create with ThreeJS. I was able to showcase my skills, my hobbies, some of the things I care about. I'm a big basketball fan, big Raptors fan. I'm actually out in Toronto. And so yeah, this is my way of expressing or showcasing my abilities with ThreeJS and with coding, but in a way that's very, very visually demonstrative. And I think that's something that ThreeJS really unlocks for you. So if any of this is interesting at all to you, if you're as excited about this as I am, I think you're going to love this course. I'm so excited for us to get started, and I think we're going to have a great time. So let's do it. Let's get started. All right, I hope that last lesson or the few examples that I provided you gives you a little bit of excitement. I hope it gets you excited to learn about the different ways that we can create these types of experiences on the browser. At least for me, seeing some of the crazy stuff that other people were able to do with ThreeJS got me super excited. And I was like, this is exactly what I want to learn, and I wanted to dive right into it. So in this lesson, we're going to go one level deeper and just explain what is ThreeJS in its essence. What is the thing that lets us create some of these experiences? So ThreeJS is a high-level JavaScript library or API for creating and displaying 3D graphics in web browsers. It makes it easy for us to create 3D graphics and animations, including 3D models, particle systems, lights, and cameras, without the need to understand some low-level WebGL code. Now, before I unpack some of the terminology for you, I think it might also be important for us to take a step back even further and understand a little bit just about 3D graphics or graphics processing in general. So what is graphics processing? Well, graphics processing is the process of rendering 3D graphics on a computer screen in real time. Now, in real time, the distinction between in real time and something that's not real time is that there's lots of ways for you to provide a 3D graphics experience for someone in something like a video. So when I go ahead and like play you a video, you're still watching some type of like experience, especially if it's like in a 3D environment where you have the camera, it's some type of animation. That's still a 3D graphics experience, except that it's not happening in real time, such that you can't really interact with it like we were with the experiences I showed you in the last lesson. You know how I can click through the screen and the experience would often follow my mouse, or I can click and drag. Well, that happens in real time, and that requires millions of calculations per second. And in the strictest sense, computer graphics is actually very, very difficult. It's hard to conceptualize millions of calculations that are required to just serve a very basic 3D experience. Your computer needs to know about each vertex of an object, where it is at any point, what color it is, where it sits on your screen. And at the hardware level, none of this can be taken for granted. There is some piece of instructions somewhere on your computer that tells you exactly what to render for each pixel of the screen. And there's so much of this processing happening that we actually invented a special type of hardware that can run lots and lots and lots of simple calculations in parallel. And that's what we call a GPU. So a GPU stands for a graphics processing unit, and it's a special type of hardware that can run simple calculations in parallel. And by doing so, it's designed to handle the demands of rendering 3D graphics. Now, to render 3D graphics in a browser, we need a way to actually communicate to the GPU. And that's where WebGL comes in. So WebGL is a JavaScript API for rendering 3D graphics in a browser using the GPU. Now, if you don't know what an API is, it's essentially a way for you to interface or instruct some underlying process. Many technologies provide you with an API or an interface to allow you to use their service, and the intention behind it is to either abstract away complex stuff, or it's supposed to hide what's actually going on underneath the hood. So for example, you don't really need to know how a car works to interface with it or to instruct it what to do. You don't need to understand like the very technical intricacies of how fuel injection works for you to drive a car. All you need to do is, understand how to use a steering wheel, the pedal, the brake, and in this analogy, that's all part of a car's API. In a similar fashion, I've heard of the analogy that a menu at a restaurant can be an API because it provides you with a succinct set of instructions to communicate and access the functions of a very complicated process under the hood, and that being, if you can imagine, like a crazy kitchen in a restaurant. You don't need to understand how all of that works. You don't need to instruct those chefs specifically. All you need to do is you need to tell your waiter or your server specifically which part of the menu that you want to access. So for us, WebGL is kind of that menu that provides us with a language or a communication protocol to talk to the GPU to instruct it what to render. Now, with any type of API, to me at least, they all exist on a type of API spectrum. And the way that I like to break this down is that generally there's a little bit of a trade-off between specific APIs and abstract APIs. And on the left-hand side, we have something like a specific API, and generally there's a type of correlation between how specific an API is and how much control the end user has over the product. On the other hand, the more abstract an API is, the more user gives up granular control of something for ease of use. So, of course, this isn't a linear spectrum. Some APIs are just better than others. They allow for more control, but are still easier to use. But we generally like to think of APIs potentially as existing as a high level or a low level API. And a low level API being those specific APIs that give you more granular control, but at the cost of greater complexity. And then those abstract APIs being a high level API, which provides you with a lot more convenience and a lot more tools supported out of the box, but perhaps you may not be able to have more granular control over your output. And generally speaking, we can think of WebGL as an API that leans harder towards the left side. So it is something that communicates directly with the GPU. However, it is a lot more complex, and it's a lot harder for at least beginners to start using Web3D to really communicate with and really program with. Sometimes it's a very difficult language to kind of wrap your head around. Luckily for us, ThreeJS is a higher level or a more abstract API that's built on top of WebGL and implemented under the hood. 3JS abstracts away some of the complex WebGL language into a more easier to understand JavaScript API to allow you to focus on more of the creative parts of the process. So for someone like me, 3JS was a great way for me to learn about these web technologies. As I've gotten a better understanding of Web 3D and I've taken on more projects, I've gotten more into the weeds, then I could start diving deeper into the actual inner workings of 3JS and WebGL and try to do more with the underlying technologies. But that only started because I had a way to kind of like get me into and introduce me to some of these web graphic technologies. And 3JS was a way for me to create really, really cool experiences in a really short amount of time without learning the very, very complex inner workings of WebGL. Now, that's not to say that because we're using a higher level API that we're giving up a lot of control. As I've shown you in some of the examples I've provided you, most of those examples, if not all of those examples, just use 3JS out of the box because 3JS is still a very, very flexible protocol and a very flexible API out of the box that provides you with a lot of the necessary tools for you to create many, many different diverse types of experiences. For me, 3JS was what I use entirely, and I was able to create that fun, vibrant portfolio that I think is different from a lot of websites without having to really get into the weeds of how WebGL works. And for a lot of people, 3JS is that kind of more specific API because, let's face it, not a lot of people know how to code. Specifically, not a lot of people know how to code within Web 3D. And so there are actually even more abstract APIs being built in the market that are basically just web builders, if you could imagine something like Wix or Squarespace, but instead they're using 3D and they're actually implementing 3JS under the hood. So as a beginner, I think this is a fantastic way to start, and I hope this course will do the same for you as learning 3JS did for me, which is really unlock my ability to create some really amazing experiences that are readily accessible to anyone with a device and a mobile connection. So if you're as excited as me, I hope to see you in the next lesson, and let's go ahead and start to learn a little bit about 3JS.
Requisite knowledge.
All right, before we get started, let's talk about a couple of prerequisites that you will need to know and prerequisite tooling that you'll need to have before we get started with 3JS. So regarding the knowledge, 3JS is a JavaScript library. It's built in JavaScript and it's also implemented in JavaScript. So some basic knowledge in JavaScript will take you a long way in this course. So basic concepts I'm talking about, if you understand what variables are, what objects are, what loops are, what functions are, you should probably be good to go. We're really not going to dive very deep into some really crazy JavaScript concepts. Most of it will be using the 3JS API. Now, if you are a developer in another language, you may have also recognized some of the concepts that I threw at you. And so, for example, my actual first JavaScript project was actually in 3JS, hilariously, because there was nothing else that I really wanted to develop. I was like, well, if I'm going to make a website, might as well make it in 3D. I've since learned a lot more about web development, and I've become a lot better of a web developer. But hilariously, my first project in JavaScript was a 3JS project, and prior to my first project in JavaScript, I actually worked on some Python projects. So I was developing in Python, and I was doing a little bit more on the data science side. So I really didn't know anything about web development. I was an amateur Python developer, and I was able to get by. So I'm sure if you have some basic knowledge of coding concepts, you will feel right at home. The next thing is some basic math. So we will be using a little bit of math in 3JS, but this is going to be the very basic math. And believe me, I don't like math as much as anyone else. So if you aren't comfortable with math, don't worry. You can still be a very good 3JS developer. I know lots of people who would totally despise math, but it will be something that we will be using and is more good to have. And then finally, let's talk about tools. So regarding tooling, I have two recommended tools. So Chrome is recommended because I recommend you use Chrome if you want to follow along exactly to what I'm doing, but Safari and Edge will work just fine as well in terms of functionality. Similarly with Visual Studio Code is my IDE of choice. You can use whatever you want, but if you want to follow along step by step, make sure that every click works properly, then Visual Studio Code may be helpful for you. And then finally, Blender is something that we will be using. in one of the lessons to actually create our own 3D scene. Blender is a 3D modeling software that's totally free and it's open source and it's amazing. If you don't care about that, if you don't want to do any 3D modeling, that's totally fine as well. You do not have to follow along. I will provide you with a model at the end of it, and we will be working with that model in ThreeJS. But I know a lot of developers who don't care anything about 3D modeling, and they don't want to even touch the design side, and that's perfectly fine as well. But if that's something you're interested in, I think you're going to have a good time, and Blender is the tool that we are going to be using. So that's about it. There's really not a lot of prerequisites. It's just a couple, some basic knowledge of JavaScript, a couple tools, and we should be able to get started. Alright, so the first thing that we're going to do is actually take a look at the documentation. And we're doing this for a couple of reasons. The first reason is I think this is best practice, and I want to get you used to best practice, because as we start progressing through the course, this is something that we're going to refer back to very often. It's not the most well-documented library, but however, it does have a wealth of information that I think is going to be really important for you to kind of take advantage of as you start becoming a better developer and start learning more and more about the library. And so to access the documentation, we're at 3js.org. If you need to, I can leave a link under the video as well. You can click documentation, it brings you to, what you would expect documentation to look like. So, you can search up if I cared about different meshes. I can go to take a look at what an instance mesh is, or a skin mesh. And obviously this has examples of properties, methods, etc. We will be using this, but right now we don't need to dive right into it, and that's not how we're going to go about this course. We're not going to go page by page and learn everything there is to know about every documented page. What I want to show you is very cool thing about this documentation is 3JS actually has a bunch of their own examples within their documentation. So this isn't those examples that you saw where it was like someone else's portfolio or someone else's website that used 3JS, and it's kind of like a black box. You don't know what's going on. It's obviously very cool. But what we have here is we have a ton of 3JS native examples where they just show how to make cool stuff. And if you click this button on the bottom right hand corner, you can actually go right into the actual raw code itself. So you can see line by line exactly what they're doing. And they have some really cool stuff here. For example, so this is a loader. You can go ahead and search anything you want. So for example, if I want to take a look at different geometries, I can take a look at how those work under the hood. I can take a look at animations. So one of the first examples is actually something that you'd be able to do with 3JS, walking characters, if you can imagine, in a game. And the coolest thing about this is that it's also a great way to learn how to do stuff that you have no idea how to do. So this is one way that I approach learning 3JS, is if I find an example that I think is super interesting, what I can do is I can actually just go into the code and I start playing with stuff myself and like tweaking examples, let's see what it does, and really picking it apart. So that's exactly what we're going to do in this lesson. I won't show you anything that I won't be showing in subsequent lessons regarding 3JS, but I will show you how to actually just access some of these examples and play with some of these yourself if that's something you're interested in. And I think this is also a good practice going forward. If you find anything you like, feel free to dig into the code and really pick it apart and find out what works and what doesn't. So let's go do that. Alright, so this is going to be our quick and dirty way of getting our hands dirty with our 3JS examples. And I guess in a way, kind of, and I'm air quoting here, like hack into some of these examples and really, get to know their inner workings. And this is one of the ways that I would recommend you to do to learn more about the internals once you start understanding, building upon your knowledge of 3JS, and you really want to see how some of these examples work. I think there's lots of opportunities here for a lot of learning. So to do this, we're going to actually go ahead and go to the actual 3JS repository on GitHub. And so I will have this linked under the video. We're going to click this big green button and we're going to just go. go ahead and actually just download the zip. So I actually have this downloaded, and in future videos we will just download or bring in this repository with npm, so we won't actually be downloading the zip as we are now. But for this lesson, I went ahead and downloaded it, and I went ahead and extracted it. So you can see now it lives here in this folder, ThreeJS master, and it has all of the actual files that actually run ThreeJS. Within this examples file, you can see that it has a whole bunch of HTML files, and these HTML files actually correspond to all of these examples. So if I actually double click one, you can see for one, it's open on another browser, but it's also completely black and we don't know what's going on. If I go ahead and actually right click and I click go to inspect, you can click Command-Shift-C on Mac or Control-Shift-C on Windows, and we go to the console tab. You can see that one of the errors that we're getting is that it's not allowed to load our local resource. So this is actually a security feature in web browsers that essentially prevents your websites that you're running to pull files from your local hard drive, and that's exactly what this file is trying to do. It's not trying to pull, from your actual data, but it's trying to pull from its own repository. But Chrome sees that as website trying to access your own files. So obviously you wouldn't want that to happen, and you kind of want this feature. You can imagine what malicious websites may want to do with that type of access. But to work around this, we actually have to just go ahead and actually emulate a web server delivering us files from our own computer. One way to do this is to actually install the live server extension from ThreeJS. In future lessons, we will just use Vite, which will provide that local development server for us. But for today, you can go ahead and install that extension if you'd like to follow along. So I went ahead and installed it, and the next thing I'm going to do after it's installed is actually pull that entire file directly into VS Code. So I'm going to go ahead and pull it into VS Code, and it's going to populate my left-hand side with all of the files within that repository. So if I want to access the examples, I'm going to go under the examples folder, and I'm going to click on any of these. Any of these will work. And click on this Go Live button on the bottom right-hand side of my IDE. Once I click Go Live, it'll actually just start a server, and boom, you can see that now it finally works. This is pretty cool. I click Q or A to move the arm. Okay, so this is a physics demo. Super cool. So this is one of the things that you can go ahead and play with if this is interesting to you. The one example, the very simple example that we're going to use involves text. So it is this example, but let's get it to say something that we want it to say. To access the actual code, we're going to go ahead and click on the bottom right-hand corner, and it's going to bring up the actual code itself. And the only reason I'm doing this is I'm going to actually search up the title or the snippet of code so that I can access something that we want it. So the one example, the very simple example that we're going to use involves text. So it is this example, but let's get it to say something that we want it to say. To access the actual code, we're going to go ahead and click on the bottom right-hand corner, and it's going to bring up the actual code itself. And the only reason I'm doing this is I'm going to actually search up the title or the snippet of code so that I can access that same file on my local machine. So I went ahead and actually just searched it up, and I just clicked the file that corresponds to it. You can see that it has the same title, so I know that this is the file that we want. I'm going to click on that Go Live button again to close the server, and I'm going to click once more time to launch the server now with the new HTML file. Okay, so now you can see, boom, instead of hosting it from ThreeJS, I'm actually now just hosting it on my own machine. So on the left-hand side is the code that runs the experience, and on the right-hand side is the experience itself. So, I mean, technically, we just can go ahead right now and just, code in ThreeJS. Obviously, we haven't been exposed to any of this yet, but I think the simplest thing that we can do right now is just change this message. So let's change this from ThreeJS simple text to this is the best course ever. Hit save, Command S for Mac, Control S for Windows, and then there we are. This is the best course ever. Obviously, this is not a groundbreaking change. I'm sure I'm not blowing many minds here. But if this is your first ThreeJS application, well, there you go. You can write anything you want, the 3D experience in the browser, and then as we start building on our knowledge of the actual ThreeJS API, I'm sure you can imagine we can do much cooler stuff than just change text. Right now, just taking a look at this, I know that color accepts a string, so I can just make this red, and then I know that this accepts a string as well, so let's make this blue. And yeah, feel free to have as much fun as you want. Feel free to go into the many other examples and see what you can do, see what you can break. You know, feel free to break it. It's not going to hurt anybody, and it's all for the purpose of learning. So I hope this has been a fun example for you. I hope this gives you a good example of some of the things that you could do with the ThreeJS examples. And very quickly, let's get started coding our own ThreeJS experiences. All right, see you in the next lesson. All right, let's talk ThreeJS fundamentals. I know that we are excited to probably jump right into the code. We're probably excited to get something on the screen. But before we do that, I think it's going to be very important for us to understand, at least at a high level, the structure of a ThreeJS application. And with that, I have that depicted to you visually here, the structure of the ThreeJS application. And this is something that we're actually going to come back to fairly frequently, because as we go through the course and we start to populate our knowledge of a ThreeJS application, because I want to really start connecting the dots for you, and I really want you to start understanding how all of these different constituent parts ultimately fit together, because it will get a little bit complex, but once we understand the structure of it, and once we have the scaffold in place, I think it'll be easier for us to start building on top of that to really develop really fun and amazing ThreeJS applications. Now for here, we have basically a high-level depiction of the ThreeJS scene, including the scene, the camera, and the render. Obviously, we also have everything that exists within a scene, but I won't spend too much time diving into that because we will inevitably start going much deeper into something like material, geometry, which make up different scene objects. But for now, we'll understand them as scene objects, which exist within the scene, and then we also will have the camera and the render being discussed in this lesson. Now, real quick, a 1-second summary of these three different objects is essentially the scene holds everything that can be viewable by the user. The camera is what determines what is ultimately viewed by the user at a given point in time. And the renderer takes information from the scene and the camera, puts it all together, and then generates an image or a series of images for the user. Now I'm going to take a few minutes to dive into each of these individual parts specifically and go into a little bit deeper about what makes it up and why it's important for our application and the different important features of the scene, camera, and the render. So let's start with the scene, because I think it's easiest for us to understand, to draw an analogy for the scene. So you can imagine a scene in ThreeJS is similar to a scene in something like a Hollywood movie. So what would belong in a scene in a Hollywood movie or any type of movie set? Well, it's anything that we ultimately want the viewer or the user of the application, in our case, to ultimately see. So that would include all the objects of the scene, all of the lighting, the foreground, the background, that all exists within our scene. Now, the difference that I want to bring out here, or the important distinctive feature of a ThreeJS scene, is the way that it's organized within this type of hierarchy. So this hierarchy right now is depicted by these types of parent-children relationships within this group and these meshes. So this group is parents to both of these meshes. And why is this important? Well, this is important because, well, one, it helps us organize the objects within our scene. You can imagine a scene can get very complex very quickly if each individual part of a scene exists independently. So an example here is, let's say we had something called like a car within our scene. Well, that car within our scene could actually be something like the group. And this would be important is if we wanted each wheel on the car, so I'm going to depict that with a W, to be a different object within our scene. And then the hull of the car to be a different object of the scene. And what this lets us do is lets us organize all of these different groups within that one parent object car. So if you want to do anything to the car, we can just apply some type of transformation to the car instead of doing it to each individual object or children of that car. And that brings us to the second important feature of this hierarchy-like structure, is the fact that given this parent-children relationship, children of a parent actually inherits transformational properties from that parent. And now, why would this be important? So for example, let's say it's a car, right? So we expect it to move. Let's say we wanted to move this car X amount of units to the right. Well, because we have independent meshes within our scene, 4 of them being wheels, 1 of them being the hull of the car, we could, in theory, move all of these meshes independently. And so all of these would be different instructions for this mesh to be like, okay, move this wheel, move that wheel, move the next wheel, so on and so forth, X amount of units to the right. Or we can just tell ThreeJS, you know what, move that car X amount of units to the right. And what that lets us do is it keeps us organized, and it lets us abstract the amount of transformations or the amount of instructions we want to do on the scene to the highest relevant level, in this case for us being that car. Now, ultimately, everything feeds up to the parent, to the ultimate parent of the scene, which is the scene itself. So the scene itself is actually a 3D object as well, and it is ultimately the thing that holds all of the different children within that environment. The next is going to be the actual camera. So the scene holds everything that we want the user to see, and the camera tells us, okay, what is the user ultimately seeing right now? And if you can imagine, just like in a Hollywood movie set, the position of the camera is going to be important, as well as something like maybe even the lens of the camera. So that lens is going to determine the field of view. And if you have a wider lens and a wider field of view, you'll have more things visible within your scene. And obviously you can imagine, given the position analogy, if something's behind the camera, yeah, it can exist within your scene, but the user's not going to be able to see it. Finally, we have our render, which is going to be a little bit more difficult, let's say, to draw an analogy for, because there's really no render within this Hollywood movie analogy. But to render is to generate an image. And so essentially what we're doing within our ThreeJS application is we're essentially taking information from the scene, we're taking information from the camera, we're passing it to the renderer, and we're telling it to render. And so that's what this snippet of code is doing here. So we're calling the render method on the renderer, we're passing it this information, we're saying, give us an image. And this is essentially what's going to happen if you call the render method once. Well, what that's going to do is going to take that information and it's going to give the user an image. What happens if we want a movie, just like in our movie analogy? Well, same considerations happen if we want our ThreeJS scene to animate, or if we want our ThreeJS scene to be interactive. Well, in that case, just like in a movie, where a movie is actually just a sequence of pictures, most Hollywood movies are 24 frames a second, we just have to call that render method X amount of seconds to make sure that it looks like a moving picture. For us, it means it's about 60 times per second for most display screens. Obviously modern displays can get up to like 120 frames per second, but this is essentially what I'm depicting here in this render loop. And so this render loop is something that gets called on average, oftentimes 60 times per second. So 60 times a second, we're telling the renderer, we're feeding information to the renderer about the scene and the camera. We're telling it to generate an image that ultimately gets passed onto the user screen, and then that user gets to experience your ThreeJS application. So in summary, we have the scene, which holds all the information about the actual experience and all the objects in a hierarchical-like fashion. The camera, which views the scene and tells the renderer what specifically we're looking at, and the renderer is responsible for ultimately delivering that experience and giving the user the images that we want them to see. All right, let's get started. Now, I know we're probably super excited to jump into the code. I am, believe me, I really want to get started. And we're right there, and there's just a couple more things we need to understand, or a couple of things we need to do in order for us to get started. So for our course, we're going to be using the build tool called Vite. Now, a build tool in the context of web development is a software tool that automates the process of transforming code, the code that we provide it, into production-ready HTML, CSS, and JavaScript that will be read by the browser. Now, build tools are used to compile, transpile, bundle code, amongst other things, and Vite is one that's specifically designed for modern JavaScript development, which means that it provides a fast and efficient way to bundle your JavaScript code with modern tools such as something like instant server start, lightning fast hot module replacement, optimized build, and really things that you necessarily don't actually need to care about. But I promise you, in the absence of it, you will notice. So, with Vite being a JavaScript build tool, if we click on Get Started here, you'll see that the one thing it'll need for us to do is actually install something called Node.js, and it actually has a required version. Now for us, I'm going to tell you to install the latest version of Node.js. So for me, I'm going to install it for Mac OS. I'm going to install the one recommended for most users, the most up-to-date one. If you have Windows, obviously install the Windows one. But before you do that, it may be important for you to understand what Node.js actually is. Because for me, at least when I started getting started in software or web development, something like Node.js, I really got confused with NPM, and you'll hear NPM all over the place once we start managing dependencies. But essentially what Node.js is it is something that lets you run JavaScript outside of a browser environment. So Node.js provides a runtime environment for running JavaScript code on your desktop, let's say, because otherwise you may understand JavaScript as a language that's understood by browsers. So something like Chrome, something like Safari, they understand JavaScript, but your computer doesn't unless you install Node.js. And something like Vite is actually created with Node.js, so we'll have to install Node.js first. On top of that, Node.js also provides us with NPM. Now, NPM actually stands for Node Package Manager, which is what confused me so much, because I'm like, is Node a package manager? Is it not? Node provides us with the runtime environment, but it also provides us with the package manager, which is used by Vite to manage its dependencies and packages. And we'll also use NPM to manage the other dependencies. One of them, I'm sure you can imagine, being ThreeJS, which you can see the first line here. It tells us you could install ThreeJS with NPM. So that's why the first thing you'll see here when we go into the actual instructions for installing Vite is to run npm create Vite at latest. And where does that npm come from? It comes from Node, which could be confusing, you know, like where does this command come from? Well, it comes after you install Node. So let's go ahead and get started. I have this empty VS Code window right here, which is actually the directory of which is actually the parent directory that I want my course to live in. So I have something called course teaching. I'm going to go ahead and drag and drop it into that, and you can see that it leaves this window right here. It's telling me that, okay, so whatever I create, whatever project I create is going to live within this course teaching folder. Now I'm going to go ahead and copy this code. I'm going to paste it in, or you can just, you know, type it up to you. I'm going to paste it in, and then it's going to ask me to make a project name. I'm going to call this project name hello-world. It's also going to ask me to select a framework. So for us, we're doing vanilla JavaScript. We are using just JavaScript instead of TypeScript. And now it's telling us to run cd hello world, npm install, and then npm run dev in that order. CD stands for change directory. So it's just telling us, okay, right now we are in the parent directory of course teaching. Let's go into the hello world project directory. So run that command. Then we're going to run npm install. So what this is going to do is actually, right now we have a package.json folder which houses all of the dependencies that Vite requires. And by running npm install, it's actually going to automatically install those dependencies for us. So let's go ahead and do that. It'll take a couple seconds. Okay, well, that was a lot faster than I thought. And then now we're going to go ahead and run npm run dev to actually run our local server, which actually Vite provides for us. So it actually provides us with a development server. So when we actually start editing our website, when we start editing the index or the counter or the main.js or all of the projects within our file, we can see what it looks like at real time. So now it served us this website. It has different buttons that go different places, and that's all within this template configuration that has provided us with this index, this counter, and this main.js. We will obviously get rid of all of this in the next lesson, but for now, if you have this running, great. Let's get started with some 3D. I'll see you in the next lesson.
I'll see you in the next lesson. ThreeJS มันใช้ทรัพยากร CPU ใช้ GPU ครับ ที่พี่ฟังเขามาเมื่อกี้นะเขาบอกว่าใช้ GPU.
Alright, so by now we should be looking at this Hello V template that we created in the last lesson. And by the end of these set of lessons, we will create our first Hello World in 3D. Now I know this red square, it's actually a cube, but right now we're facing directly in front of it, so it's a square, isn't something super fancy, but I promise you, we will very quickly be able to build really cool experiences that you may have never thought that we'd be able to create without this new type of framework. So, before we get started, I would also like to point your attention to two things. One of it being the actual 3JS fundamentals document. Once again, I said that we will be referring back to this as we build out our knowledge of a 3JS application and the structure of it and where all parts fit together. And as well, I want to point your direction to the docs. Now, this is a habit that I want you to get used to because, you know, as we start getting into the weeds of 3JS, you will find it hard to potentially maybe like the different methods and properties that are unique to this type of 3D program. So we'll get started here with creating a scene if you'd like to follow some of these instructions yourself. Obviously, you can follow along with me, but I just want to get you into the habit of eventually, once we start diving deeper into things, really understanding how to pull information out of the doc. So feel free to take a look at creating a scene, see if you understand a little bit about what's going on, or maybe you can try to understand at a high level. Then obviously, you know, come back to the video and we will go ahead and take you step by step to get you to a functioning 3JS application. Alright, so right now what we are looking at is the index, the main, the counter.js, basically the files that were created in this template project that Vite has provided for us. So a few things that we'll need. So you'll see that if you actually look into the actual creating a scene, they have their own, you know, HTML that you can throw in. What I advise you to do at this point, and we won't be doing this in future lessons because I will be providing a starter, but for now I will just start, you know, removing some of the things that we don't need. So obviously we have, you know, some boilerplate HTML stuff. We don't need this div. We are also pointing the source to this main.js. Obviously this main.js is responsible for rendering a lot of the stuff on the screen right now, and I'm gonna go ahead and actually delete all this. I'll go ahead and save it. I'll also remove this counter file because we don't actually need that. We're no longer importing it through main.js, and I'll go ahead and save both files. And that's, for me, that's just Command S, Control S on Windows. Now, let's go ahead and see what's going on. So we have a blank page, and that's expected because obviously we aren't putting any HTML in. But did we load our main.js file? Well, we can go ahead and click console.log and then do like a hello world. So if it loaded our main.js file, we will see our hello world in our console. Now, how do we find our console? Well, there's a couple ways. One of them is actually to right click, inspect, and then boom, you can see that we have this window pop up. We can click it and go ahead and console. Okay, first of all, we see hello world. That's great. That means we have successfully loaded this. As well, though, I want to show you there's also shortcuts. We can use Shift Command C on a Mac or Shift Control C on a Windows to pull up our console, and that takes us to the same place. If you don't like where this console is or where it takes up in terms of the screen real estate, you can click these three dots on the right, and you can choose on the right hand side. You can also choose on the left hand side, or you can have it as a separate window. I'm going to keep it on the bottom because that just fits the screen real estate better. And now we can get started within actual programming in JavaScript. Now, the one thing that you may have noticed is we actually haven't installed 3. We don't know where it is, no idea what to do. Like, how do we have access to this library? Well, if you go into the installation page, you can see that it tells us to run npm install 3. So let's go ahead and do that. I'm going to click Control C to stop this terminal, Control C on Mac and on Windows. And I'm actually going to paste this in. So let's go ahead and install that dependency. And then we are going to follow the introduction. It's going to tell us to actually import the entire 3JS core library. So let's go ahead and basically copy this. We're going to go ahead and paste it in, which means that we're going to import the entire core library, which is what is denoted by the star, as 3. From 3, and 3 is essentially the name of the folder where it lives within our actual node module. We're basically saying, okay, import the entire library as denoted by the star as3, which is the name of where we're going to store that whole library. It's the variable that we are assigning this entire library to from this location. That location is actually pointing to this section of our node modules. So how do we know that it's installed? Well, instead of, creating an entire application to know whether it works or not, let's go ahead and actually first we have to get our development server back up and running again by running npm run dev. Follow that link. Obviously, I was already on that link here, so it automatically refreshed. And then we are going to say console.log 3. So once again, I said the entire library is stored within this variable. So if I log it out, we should see that we have access to every class that ThreeJS provides us. Perfect. Okay, that's exactly what we want. And I think we have enough to get started with the first big part of our application, that being the scene. So I'll see you in the next lesson. Let's start with our scene and let's add that to our ThreeJS application. Alright, so let's go ahead and add the scene to our ThreeJS application. Now, if you remember from the ThreeJS fundamentals lesson, we talked about the scene as basically like a container for other objects. So obviously as part of this lesson, we won't just be adding the scene, but also an item within the scene that the user is going to be able to see, because you can't just see the scene. It's where things belong, but we actually need to populate it with those respective things. So let's go ahead and add the scene to our ThreeJS application. We do that by doing const scene equals a new 3.scene. And you will see this pattern arise a lot of the times. Anytime we want a new ThreeJS object, we call new 3, which holds all of our ThreeJS classes. And then we're going to call the actual class in an uppercase, followed by the brackets. Next, we're going to actually add a mesh to the scene. So if we actually look at the diagram that we have here, so we have meshes that are composed of geometries and materials, and those are the two arguments that we're going to pass to a mesh, and we're going to add that mesh to the scene. You will notice here that I'm going to go fairly quickly, or I'm not going to go too in detail about the different types of arguments, the different types of materials and geometries, because there will be subsequent lessons that will explain the specifics of something like materials and geometries. For now, let's just get something on the screen so that we can start playing with our ThreeJS application. So I'm going to specify the thing that we want to add to the scene by doing const cube mesh equals new 3.mesh. And then it's going to take two arguments. So you can see our mesh takes two arguments. It takes a geometry and it takes a material. So let's go ahead and actually pass that to the actual cube mesh. So we're going to call cube geometry, cube material. Lowercase, I'm going to do lowercase. And then because we haven't specified that, we're going to do const cube geometry equals new 3.box geometry, which is actually what the cube looks like if we just pass it length, width, and height being the same length. And then we'll go ahead and actually pass a cube material, which is going to be a mesh basic material, which is a type of material within ThreeJS that obviously I will explain a little bit into the material lesson, but the arguments of which we're going to pass a color. I'm just going to say red. It can handle strings. And then it's basically just going to provide us with a material that does not respond to light, so it'll just look red. We don't have to add anything else to it. So now that we have these two arguments, we can go ahead and actually log them out. So let's see console.log cube mesh, and then let's go ahead and log out our scene as well. Log scene. I'm going to save, and then I'm going to go into our application. I'm going to go into our console. So you can see, okay, so we've created a mesh. We've created it with the box geometry. Okay, so that was done properly. And we've also created it with the mesh basic material. Perfect. All right, and let's take a look at the color. R being 1, the others being 0, 0. So red is 1, green is 0, blue is 0. So it's going to give us a red box. That's perfect. And then let's go ahead and look at our scene. So our scene actually still doesn't have any children inside of it. Why may that be? Well, as I've alluded to in our actual 3JS fundamentals, there's this parent-children relationship within our scene itself, but we have to be very explicit regarding what this relationship is. Now, for something like a scene, it may be intuitive to think that, well, okay, well, it's a scene. Obviously, everything else is children of the scene. But in 3JS, you can actually have multiple scenes. I've taken advantage of that paradigm, but like traditionally, it's not unexpected for you to just have one scene, so it may be unintuitive to kind of have to explicitly call that out. But at the same time, perhaps this mesh, we don't want to add directly to the scene, because anything that you add this mesh to becomes this parent. For example, maybe I want to add this mesh to the actual group itself, and then add that group to the scene in a later step. So for us to tell the 3JS application that we want this mesh to be within the scene directly, we actually have to be very explicit by using the scene.add method, and this add method belongs to any type of 3D object. So we can add a mesh to another mesh if you want. You can also add a mesh to a group, which is another 3D object. But for now, we're going to add the cube mesh to the scene, and we're going to go ahead and console log the scene again. And then once we take a look within the scene again, we're going to dive into the children. Okay, and there it is. There's our mesh. It is now in the scene. Now, for us to actually look at the scene, we will need to have our camera. So obviously, we have this camera here. For some reason, it is missing this little diagram, which I'm going to crudely draw, where you can see that the camera is responsible for looking at the scene. So let's go ahead and add that in the next lesson.
Camera. Render.
So now that we've created the things that we want the user to see, we want to add the camera to the scene to specify what the user sees, or from what perspective the user sees those objects. So we do this by going ahead and initializing the camera, doing const camera equals new 3.perspective camera. So a perspective camera is a type of camera, but it's also the type of camera that we will most traditionally use. There will be a full lesson on cameras, I think, immediately following this. But for now, we're going to provide it with a few numbers. One of them being the field of view of this perspective camera. The next one being an aspect ratio of the actual scene itself. Now, an aspect ratio is just one number divided by another. So we can actually provide it with any number that we want. But in order for us to actually specify the proper aspect ratio of the scene, we have something within our browser called the window object. And the window object has two properties within it. Let's go ahead and check it out. Console.log window. So we can see the window, and we can see the different properties within it. One of them being inner width, and one of them being inner height. And so those two properties can tell us definitively within an application, okay, so what is the actual aspect ratio? Because obviously this aspect ratio being width divided by height would be something like 16:9 perhaps. This may be 3:2, this may be 1:1. And then obviously anytime the user starts adjusting their windows, starts adjusting the application, that aspect ratio will change, and we will need to make sure that we're telling 3JS what that actual aspect ratio is. So to do that, I'll show you that we can go ahead and actually access the inner width, and we can also access the inner height. And let's log both of those out, and you can see, okay, so we have the inner width in pixels, which is obviously a lot greater than our actual height. And we pass that as a ratio, and to pass it as a ratio, we go ahead and copy this, paste it in, divided by inner height. So I'll actually just go ahead and split these arguments out so it's more viewable. And you can see the next two arguments that we pass to it are actually the camera near property, which is anything closer than this distance you will not be able to see. So I'll do something like 0.1, and anything further than this far property you won't be able to see either. So I'm going to put 30, and I'm going to go ahead and save it. Now, we haven't done anything with this camera yet, but first I want to basically show you what's going on here before we actually run into this mistake. So what we've actually done right now is we've actually initialized the camera and a mesh in the exact same position, because we actually haven't change any of these positional properties of the actual mesh we created and the camera. So they're all at 0, 0. So let's assume this part of my screen here is 0, 0. The camera right now is actually pretty much inside of the mesh because it exists within the same area. Now, if you can imagine, if you had a camera inside of something, it would be very difficult for you to really see what that something is. Now, what's the solution? Well, maybe it's worth it to move the camera back. So that's exactly what we're going to do by actually manipulating a property of the camera called the position. Now, this position property exists on any 3D object, which alludes to the fact that this camera is in and of itself a 3D object. So we can go ahead and do camera.position. Now there's X, Y, and Z properties. I'm going to tell you that we want to move the Z property back, but obviously that's not intuitive at first. So we will, in the following lesson, have an explanation about different axes and what those mean. But for now, we're going to access the Z property and we're going to set it to 5, which is actually going to move that camera back. I'm going to save. Obviously, we have nothing yet because we haven't called the render method on the renderer, and we don't even have a renderer. But as well, I'm going to do one more thing, and I'm actually going to go ahead and do scene.add camera. And the reason for this is just to demonstrate the fact that just because it's a camera doesn't mean it's not still a ThreeJS object. It's still a 3D object. And for that reason, we can add it to the scene if we want. We can also keep it out of the scene, so it works both. You don't actually have to add it to the scene, just like, for example, for a QMesh, you have to add it to the scene. A camera, you don't. But it could be important to add a camera to different 3D objects. So for example, if we wanted to add it to a car, then the camera would be able to, have that car's point of view, and that would obviously be a different, interesting experience for the user. So I'm going to show you that we can, but I'm also going to, at the same time, leave it out. And then in the next lesson, we'll go ahead and initialize the render. And so we'll finally have something on our screen. Few lessons. All right, I know that we are a few, maybe a little bit more than a few lessons in, and there's still nothing on the screen yet, but that's going to change by the end of this lesson. So let's drop in. All right, so if we take a look at our actual ThreeJS fundamentals document, you can see that the last thing we need is this render. And this render is going to take information from the scene and the camera. We're going to call the render method with the information from the scene and the camera on the renderer, and it's going to provide us an image. Now, up until now, I don't think it's been clear, at least it wasn't clear to me, where the actual image is going to exist. If you have a fundamental understanding of HTML, or at least a basic understanding, you'll know that this right here, this HTML, this constitutes essentially everything that the user is going to be ultimately seeing on their web page. And right now, there's no reference to any type of image or any type of part of this website that's going to display this image that's generated by the renderer. And that's where the actual canvas HTML5 element comes in. And so this canvas element acts as a drawing surface for rendering 2D and 3D graphics. And I think the name canvas is a very well suited name, because if you can imagine a canvas in painting, it's the surface that we are going to be drawing on. To add this canvas to our actual website, we go ahead and write canvas. We pass it a class, and this class can be anything that we want, but I'm going to call this ThreeJS. It was going to be easy for us to go ahead and find within our actual application, and then I'm going to close it out, and it's going to look like this. So I'm going to go ahead and save, and then within our actual application itself, I'm going to go ahead and actually retrieve that from the HTML document. And I do that by doing const canvas equals document dot query selector, and I'm going to pass it in a string, that string being canvas.3js. So this 3js is referencing this class that we provided. The canvas is referencing the actual element itself. So let's go ahead and log that out to see that we actually have retrieved the canvas properly. And it looks like we have, perfect. And then let's go ahead and actually now pass it into the render. So the render is new 3.webgl render, and then it takes the canvas as an argument within an object. So within this, we actually pass it an object, and that object is canvas. That's essentially what we're doing. But if you want the quick and easy way, JavaScript allows you to basically remove this redundancy and basically pass it like this. But essentially, we are actually just passing it as an object with the canvas element being the canvas. All right. So the next thing we want to do is render the scene. So let's go ahead and render .render, and then we pass it the scene, we pass it the camera, and we save and see what happens. Voila. I know it's not what I promised, so let's figure out what's going on. So right now the render actually doesn't really know how big you want to draw it. And the way that we can specify is this, we can actually call this method set size. So set size takes two arguments. It can take width and the height, so we can specify that to whatever we want. 500, 200, we can make it really wonky. But, you know, as you may remember from our lesson about the camera, we actually have access to exactly how wide this window is and exactly how high this window is, or how tall it is. And if we actually set the size to the window inner width and the window inner height, we can go ahead and make sure that it fills the screen. So there we are. Now we have a full screen experience, you know, obviously minus these margins, which we will fix with CSS styling in the following templates. But yeah, now we actually have something on our screen. It is not yet interactive. That is coming in the future episodes. I hope you're excited. I know this is not something super fancy, but I promise you we're going to create some really cool things really fast. I will be walking you through it step by step, so I promise you we'll make it very accessible, but the range or the extent of things we're going to be able to do is going to grow very, very quickly, and I'm very excited for you to go through this process. So I hope you enjoyed this. I feel like this is going to be a great course. Let's do it.
ชั่วโมงแรกจบชั่วโมงแรกเรนเดอร์กล่องสีแดงลงหน้าเว็บครับชั่วโมงแรกคอร์สนี้6ชั่วโมงเดี๋ยวว่าจะมาเรียนให้จบเลยแต่วันนี้ก็กี่ทุ่มแล้ววะ4 ทุ่มเดี๋ยวไลน์เมื่อกี้ชั่วโมงพอดีนี่แหละเรียนวันละชั่วโมงเดี๋ยวไปว่าจะไปออกกำลังกายละนะฮะสวัสดีทุกคนนะครับเดี๋ยววันเสาร์ไม่แน่อาจจะมาอยู่แต่พรุ่งนี้ไม่มาเพราะว่าพรุ่งนี้มีมวยวันเสาร์ไม่แน่วันเสาร์อาจจะมีแขกรับเชิญเดี๋ยวรอดูนะฮะคืออะไรครับพี่มันคือไลบรารีในการทำ 3D ครับให้บนเว็บเพราะว่าเดี๋ยวจะมาสอนในช่องก็เลยมาเรียนรู้ไว้ก่อนจริงๆเคยสอนไว้แล้วแหละแต่ว่าเป็นพื้นฐานแต่อันนี้ก็มาแบบมาทบทวนมาเรียนให้มันลึกๆโอเคครับเดี๋ยวไว้เจอกันใหม่แล้วกันวันนี้ก็สั้นๆชั่วโมงเดียวเดี๋ยวพรุ่งนี้พรุ่งนี้ไม่มานี่หว่าแต่ไม่รู้ว่าถ้าแต่ก็อยากมาไลฟ์อยู่มาไลฟ์เรียนวันนี้ชั่วโมงหนึ่งพรุ่งนี้ไม่ใช่พรุ่งนี้วันอื่นอะวันอื่นก็อาจจะวันละชั่วโมงโอเคเดี๋ยวไปออกกำลังกายแล้วนะครับวันนี้ก็